NRGFPV here. Right, the energy wing tails, that's where I finished off last time. They have printed, so it was a good solid 12 hours of printing for two of these pieces, and they did work fairly well straight off the bat. Quite happy with them. The unfortunate side to it all is that the V in the front of it, just through here, when you're fitting it to the wing, does not quite fit correctly. The tail fin doesn't go far enough forward. So what I have to do, what I figured I would stream today, is modifying the CAD files to enlarge that V so it sits further down over the tail. Seems like a pretty basic thing to do. It's actually quite not basic to do in Fusion. Fusion can get quite curly when you're trying to do little details like that. And I'm sure there's a million ways to do this within Fusion because it is such a powerful piece of software, but I've been using it for 2 years now and it's still a daily struggle to meander my way through it. So, not the sharpest tool in the shed, but let's give this a go. Now, so this is where I finished off last time. This is the wing with the two tail pieces. I have exported the tail pieces away from this wing into a separate file up here. That's it there. I've done this because it's a bit easier for the computer to work with one mesh at a time, and the less that there is open, the easier it is for it to process everything. Where to start from? I've already come in and edited out the lump, the key point that fits in here, just to a flat mesh. And the next thing I need to do is expand these two surfaces outwards, basically. So, how can I do that? Well, the way I've found to do it is that I use this piece of the tail to intersect into another block that I create in here. Take that tail form shape, basically use this tail as a tool to remove material from another block, which then leaves me the internal piece of the V, and then I take that internal piece of the V and expand it outwards, and then use that back in the V, and then use that to cut out the V on the tail itself to larger. I only want about 1mm difference. There's probably a tool where I can just select these faces and then tell it all to go outwards by 1mm, but I don't know what it is. So this is the way I know how to do it. Well, I've worked out how to do it. It's a little bit long-winded, but hopefully this goes smoothly for me this time. So what I want to do is create a new block that encompasses this whole V section. So what I'm going to do is I'm going to create a sketch of a block around the size of that tail piece there. Sketch finished, and I want to turn that into a 3D block, so let's make it longer than the tail. Oh, no, I don't want to cut it out of the tail. I want to create a new body. I also want to extend it forwards as well. Cool. Okay. So that will now give me, if I dissect basically material from this block using this tail fin as the tool. Sounds backwards, I know. So how am I going to do that? Something else that sounds backwards, combine. To do this, you actually have to go to the combine function and go from intersect or join to cut. I want my target body to be this block because that's what I'm targeting to be cut, and my tool body will be the tail itself. And I want to keep the tool, because if you untick this, the tail disappears once you've done the function. I've done that. Now it looks the same, but if I hide the tail body, it's cut that shape out of this block. So how do I use that? Well, I'm going to delete all the exterior surfaces and make that V now a solid shape. So we go to the surface function. Surface is a crazy tool, but basically I can pick any of these sides or these surfaces and delete it. Delete. 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 And delete. Look at that, I'm left with the negative shape. Now the bit I'm interested in is these interior faces in here. So let's keep deleting. Oh, computer's having a heart attack on that one. Delete that bit there. Don't know why it's left these. Anyway, I can't delete them for some reason. They just look like vertices, not actual solids. Ah, there it is. Delete. Alright, so now I'm left with this just little wedge shape. Now I'm going to turn this back into a solid. So basically you're going to create a wall from here to here. How can you do that? With a patch. I want my boundary edges to be that there, and voila, I now have a wedge with the exterior shape of that wing. So we'll go with that. There, that's processed. Now it's come up as a solid. So we can go back into the solids menu and work with this again. Now I need to make this surface and this surface go outwards by 1 millimeter. What a trip just to make a tail wing, a wing tail. Hey, and thank God there's no cat in here this time. So how can I do this? I don't know. Let's find out. Let's scale it up. Okay, cool. Scale factor 1. Let's give that a go and see what it does. No, obviously not. The scale of 1 to 1 is the same size. Duh. Alright, let's try scaling this again to... Well, I only need 1 millimeter difference. So let's actually take a measurement of... Well, it's even hard to measure because it's a very odd shape. Let's find somewhere that I can take a dimension. Let's see if we measure from there to there. 32.89 millimeters. Get my whiteboard marker and write that down on my desk. 32.89 millimeter. Alright, that's noted. Now, try scale. So let's scale this by 0.01 and see what it does. Measure again. From there to there. 33.89 on the... Sorry, 33.27. And the original was 32.89. So it's gone up a little bit. That's good. Let's reverse that. See if we can see a height measurement anywhere. Because it's a wedge shape, it's hard to pick somewhere that could be a measurable surface. Let's go from there to there and see what it spits out. Can't do that. I wonder if I can draw a line across these surfaces and measure from the surface to surface, the line to line. So let's sketch a line across. No, won't let me sketch on that surface. So, this is a hard one. Alright, I reckon I'm going to go with just wing it, excuse the pun, and scale it up by 1.02. Now that looks like it's done nothing at all, but let's check the measurement on here again. .556, so 32.89. Let's make it scale up a bit bigger. Scale, uniform, yes. 103. I've just noticed something inside of this menu. It said uniform in there. So let's just quickly undo this. Remember, 0.03 as a good... It looks right. I don't know the maths behind this, but it looks right to me. So I'll just wing it and see what it does. But let's just have a quick fiddle and see if I can scale in a non-uniform manner. So it's given me two options here. Now if we center it up, it's given a vertical and a horizontal option. Let's just drag it and see what it does. Alright, cool, I can stretch it that way. Cool. I don't want to combine, I want to scale, where'd it go? Scale. Non-uniform. We want to go upwards by 1.03. That appears to have done the job. Let's turn the original tailpiece back on. As you can see, it sits in there quite nicely and it overlaps. We'll zoom in, and there most definitely is an overlap. It's not much. Let's make this a little bit larger. The thing is, the V shape is keeping the same profile of the wing, and that's what I want, because when I'm using this tail plug on the wing, I'm actually going to fill it up with epoxy resin and then push fit it onto the tail of the wing and get the tail of the wing to do the shape molding for me. So technically all I'm doing right here is creating a space for that epoxy to exist in there without overcooking it and having a 3 or 4 millimeter gap that's to be filled by the epoxy. I only want about 1 millimeter, maybe 2 millimeters at the most. So I reckon I'm on the right path. So let's go backwards and rescale again. Scale. We want to scale on that axis 0.05. That looks way better. Turn that body back on, and there's a massive overlap, which is beautiful. I wonder if I can measure from that to that. I don't think it will let me, but we can try. Distance 0.1 millimeter. Okay, so I can do it this way and actually get a tangible answer. Good. So let's go back to scale again. Non-uniform in that axis. So let's go 0.1. Okay. Turn the tail back on. See if we can pick the two vertices. Inspect it. Why is that not giving me a distance this time? Close. Try the top one like I did last time. It's not giving me a distance, which is strange, but I don't fully understand it, so I'm not even going to try and explain it. Actually, yes I am, because I've just realised they're coming to a singular point here and a spread point here. So there isn't a defined distance between the two, because the V hasn't expanded exponentially, because they're still coming to a single point. The V wedge itself has expanded, but that tapering distance is obviously different from the nose to the tail of the V. Whatever, let's just run with this. The original one gave me a 0.01 millimeter expanse. I've just gone up by a factor of 10, so this should give me a millimeter difference. Alright, let's subtract this shape from that shape again. So we go cut, correct. The target body is now the tail and the tool body is the wedge. The computer's having a little heart attack trying to think about this. It doesn't like that for some reason. Let's just move this and have a squeeze and see what's going on. So we go to the right hand side of it. I'm going to translate to the position geometry. I'm going to move this out by see, this is why Fusion catches a lot of people very quickly, and it's got a steep learning curve. I wanted to move the body, but up here it says faces, so I have to actually change that to bodies. Change that again. It's in translated geometry. Bring this out by, make it a flat 100 millimeters, negative 100 millimeters, so I know where to put it back exactly where it was. It's saying that the overlap is too close. Let's cancel that. So when I've made this wedge, the exteriors are too close to each other, and it's giving an error because it may have too many intersections. There's no clear defined intersection because they're so close. So let's make this a little bit larger widthways, and then hopefully that'll clear up the intersection. I want to scale again, but this time we'll go out horizontally. We want to go out twice as large. Cool. Now that should keep the same profile still on that wedge, and the same angle, just larger. No, maybe not, but we'll give it a go anyway. This is the sort of thing I think it was complaining about before, that it's just a bit more obvious now. So if we skip this, move it across the bodies, and translate, we go from the exact viewpoint and we shift it across like that. Alright, that's all in. That's all in. and there's the cut lines. That's pretty bloody close, but it's obviously shifted a little bit. I need a bigger screen. Oh, let's clear this off and maybe that'll help me. There we go. Alright. Let's try again. Subtract time. We're going to cut the target body with the tool body. Look at that. It'll let me do it. Hide the tool body. Let's bring the original tail fin back, the other one, and compare it. Move this body over a bit because it's overlapping. So, you can quite clearly see here that I've removed the key lump there. The angle appears to be similar. And the front piece here is also thinner. Now this piece here is only about 3mm thick. So that has definitely dropped off close to 1mm, which is good. So what I'm going to do is print these two halves now and test fit them and see how they go. Once I know that they fit right, I'll probably make a video on using the epoxy to create the keyway and the new tail molds. But I hope you didn't get too bored and you might have even learnt something off that. And once again, if you know better about this and you got some tips, feel free to write to me. I'd love some information. Everything I've learnt here, I've learnt myself. And yeah, anyone that's better at Fusion, I'd love their assistance on this. But anyway, have a great afternoon. Don't work too hard. Oh, and enjoy the public holiday tomorrow, Monday. See ya.